Okay, so the fake go live's going. I don't know how to even. I gotta get into the other studio. I think I gotta hit this button. Come over here. It says we're live.
But are we?
I can't hit the button.
Oh, it says end stream. So, oh yeah, we are live. It's official. It
Cool.
worked today. Good morning.
Good morning, everyone. How's everyone's Saturday going? No
Did we
response.
pause to let?
Yeah, we
Did we
paused for a
pause to let
tech.
people
That's
answer?
like the chat. That's where the chat's supposed to come in with something.
Oh.
I told I told Grandma she could answer in the chat or ask questions in the chat, and
That's awesome.
so maybe we'll get something. She'll be like, "I'm doing great." I don't know. Are you on our
Nope.
YouTube thing? Can you see concurrent viewers
Yeah.
or anything? Do we have anybody?
Uh. Nope.
Okay. Well,
Nobody.
doesn't matter. We didn't expect anybody because we don't do this for the fans.
No, we do it for
For the funsies.
yeah, because we like getting up early and just hanging out together.
Well, you had to ruin it with that last part.
I know. That was totally for you.
Oh man. Oh man. So, all right. Today is let me scroll up because I was reading and I'm going to switch over to the browser for those that are viewing us. If you did not read the title, which is sometimes possible, I have a coworker that writes in the meeting descriptions. It's amazing. You know, he actually puts what's going to happen in the meeting in there. And he's like, "Did you read the meeting description?" And it's like, no, nobody ever puts anything in there. But I happened to the one time that I was on a meeting with him, and it was just so helpful. So, yes, if you've read the title, today we are going to create a blockchain with Python.
Ooh, I can't wait. I'm so excited.
And we're also going to really talk about the components that make up a very simple blockchain. Maybe touch on the extra stuff that they add in to make it useful, because ours won't really be usable by the end of our 1 hour. But maybe we'll keep working on it in the future, and then that way it can be a little more usable. We're going to use our own PTP coin that doesn't exist, but it
Not
does for
yet,
today's
anyway.
purpose. Yeah, not yet anyway. No, we're not going to create a cryptocurrency. We will have NFTs, but we won't do a cryptocurrency because I don't want to be part of the group that gets it all robbed. You know, like that
Oh yeah, that would be
story where
bad.
you lose like $30 million because you have a bug in your code or something. That's a lot of. I try to,
Responsibility.
yeah, I try to keep my code as bug free as possible, but that's all. I mean, that's a lot of responsibility.
Yeah, I agree with that. Let's not do that.
Yeah, yeah.
We'll just pretend.
We'll just pretend. We'll have her pretend once. So, all right. To recap. Oh, I'm not sharing my screen. Why'd you? There you go.
I hadn't noticed. Sorry.
I know you were looking for that one chat coming in, right? That's that we were
It's just
waiting.
making. No, I was making sure that we were live. I pulled up our chat and um, which for some reason took me a surprisingly long time to figure out. So sorry.
Well, that's really part of this channel, right? I mean, because
Yeah.
everybody that watches the videos that are out there a lot, they're all smooth and everything happens perfect for the most part. You know, they'll give you a blooper one every once in a while, but no,
Yeah.
everything's
Every
perfect. In our
episode
case,
something
it's just a
happens.
disaster. Yeah, it's every episode.
Every episode is a blooper episode. But everybody loves bloopers, so
Yeah, that is true.
maybe that's what we should have called our channel. Everybody loves bloopers. No.
That was just I was thinking of Ray Romano doing it, like talking,
Yeah.
because everybody loves Raymond. So it was just kind of funny. I was doing the his voice in my head, and he would be a perfect host for it. So it would just be
Oh, yeah,
great.
for sure.
Because yeah, I mean, isn't that America's Funniest Videos? And and
Yeah,
it's
no,
still
that's a good
that
show.
show's still fine. I think it's a good wholesome show. It's got a little risky these days compared to the old days, but it was always
Yeah.
on the edge. You know what I mean? It was like
Yeah, no, for sure.
it cut the way for MTV's JA.
Oh,
So
yeah, for sure. I was like, what's that?
yeah, yeah. And so you know, but all right, back to blockchain. So
Yep, let's do it.
recapping from last week. Oh yeah, let's we don't have a little slide that says we're not a financial advice and you shouldn't do what we're doing, and definitely consult professionals. So anything we say is totally for funsies, and um, use it at your own discretion. But we do feel some of the pieces, maybe like a sentence or two, is really useful. So hopefully you do learn something and it just gives you more information to make a better informed decision when you are trying to understand what's going on with cryptocurrency, or really the new web 3.0, I guess, is what the whole encompassing thing would be: decentralization, stuff like that. So, and they're really big words and they're flashy. So to recap, blockchain. I found this and I think it's really good for the people that are only listening. We can divide blockchain into two simple terms: a block and a chain. And so the block is a space where we store our transactions, and the chain is the link of those blocks. So it's a linked set of records. Pretty straightforward. I was like, that's a very basic way to explain it.
I
So
like that too, because I mean, blockchain isn't a big word, but it can, especially thinking about um, cryptocurrency. And if you don't know a lot about it, like I don't, it's hard for me to like break down words. So it seems really simple, but at the same time, it's like, oh yeah, okay, thank you, thank you, person, for breaking
yeah,
that down. Okay,
yeah.
cool.
And this is
Thank you.
on to give them their shout out, Geek Flare create a blockchain with Python. So we have a few of those sites up, and on their page, it really is that simple. So the block, the transactions, I'm giving one PTP coin to Darcy. Darcy
Yes.
is now so rich that she decides she's going to give half of that PTP coin to another person. Who are you giving it to?
Uh, um,
I know I put you on the spot, so you got to
Jeff.
call it. You're giving it back
No,
to
I
me.
was looking at it. I was like, wait a second.
Yep.
I'm going to give it to Jeff.
Yep. So we are describing. Oh, nope, that doesn't work when you don't show it. We're describing these transactions, and they're going to get stored in the block. Okay.
Okay.
And
I'm
then,
going to answer for everybody.
yep, yep, that's expected. And so then, once you commit that block to the chain, so you're gonna hook it up to the chain. Now it's part of the chain. So then you can see all those blocks in order as they were put on the chain, one by one. You can't put them side by side. They have to link front to back. Because in programming we have lists and other structures that help with this, and we can use the words from programming. But when you're really thinking about it, it's just like you're in a line, in a queue, whatever way you want to think of it, and that is the chain. So when people talk about blockchain, the block is just a bunch of transactions or information. That's even more simple. It's just information in a chain, in a queue, in a line. And you can go through that line and ask each person in line their information. So you can look at each block and see. And if somebody tries to swap somebody in the place of the line with different information, the person before and after them will know, because they were connected to them, and they'll be like, hey, you're not that same person. So that's where blockchain introduces some really interesting features. Oh, now I'm not back on the web page. This is really complicated today. I gotta switch back and forth. So, the blockchain introduces the history of immutability, information persistency, and no errors within stored data. So let's take the first one because that's probably the most important aspect of it. You cannot change one of those blocks without changing the whole chain. So that is where it gets its security. And if there are 5 people that know everything about that line, you're not going to be able to pull that off, because if you try to do it, one of those 5 people will be like, no, that's not it. The second person will be like, no, that's not it. And that's, by the time you validate all 5 people, they're all agreeing that somebody's changed something, and they will discard that change or whatever is corrupted and just put back what they have and move on with their life. And so that's what blockchain is. So if somebody tries to change one of those blocks, if somebody tries to change a transaction within one of those blocks, it changes that whole block and the chain will know. And if what they have is nodes, if the different nodes that store the information find out about it when it goes to validate this new block being put on, or that validating that change, they'll reject it and it won't be allowed to be put on. And that's it. So that's where you can't change it. Then the information persistency, if you have 10 computers that know about this chain, so now we're going to move it back into the computer world. You have 10 computers that know everything about this chain, and when you go to put a block on, you have to validate it with a handful of those computers, and then those computers will tell the rest of the computers about the change. So then if one computer goes down, everybody still knows all the information. It doesn't affect anything. So you no longer have outages. So then the network can keep going. And then there's no errors within the stored data because nobody can change it. Now, there are bugs because it is just code. So that last one, I don't know if I would use those. I don't know. It just depends how you read it, right?
Mm-hmm.
Because we were just talking about somebody stealing bunches of money. But in general, it really, I think it has to do with manipulating the transactions in a way that you can do it. Or maybe, I don't know. I've never really looked into how people drain the different projects, but they don't do it out of Bitcoin. That's one thing that I've never seen. So
I'm excited. I'm get more and more excited the more I learn.
So it doesn't have to be a complex program. We're gonna do it in. Let's go back. I'm gonna look real quick. The main part was
You're not
less than 60. No, I was just looking.
Okay.
Because I'm still on that page. So we're doing it in less than 60 lines of code, not counting the lines to call it, but so then it's like 66 or something. But then I could take out the space lines, but it won't be as pretty. So we're going to build a simple blockchain. And we're going to the other example, which is this one. And what we have to do, now we're going to have to get into some computer words, but let's avoid those for a minute. So we have a block, and then we have the chain itself. And remember, we talked about what the block was. It's the information. It's the transactions. So we need a variable to be able to store those, right?
Yep. As
people put in their transactions, we need somewhere to store those, the place of information. So in computer programming, you have variables, and you can store characters, letters, and we call them strings, and you can store them in there. So you will record the information of the transaction, in a spot in the block. Then you also need to keep track of the chain. So you will have two parts to your block. You'll have pending transactions and chain. So that'll be just the list of the blocks, and then the pending transactions, what's getting ready to be committed. Any questions?
Nope, not yet.
All right. So oh, go ahead.
Just as a reminder, I think we should make sure to put the URL for this page in our description so that people can.
Yes, we will.
We'll make sure to do that.
And this page is from medium.com, CoinMonks, and then another Python tutorial. But they probably write lots of good code things. I don't know. I just Googled Python blockchain examples. It's pretty simple. And they came up, and theirs was a nice clean example. I like theirs the best is for the most simplistic code. The other ones I had up, that I do have up, they're a little more complicated, but they're still good too. Then what is in this block? So that was what is the chain's definition really. And it's just really a list, and then the pending transactions. But within the block, you have an index. So you have what number of the block it is. So we'll start counting from 1, and we'll go to 2, 3, 4. So every block we put on will have an index, and it'll go up by 1. We call that incrementing. Then we're going to have a timestamp. When was this block created? We definitely want that. So we'll put a timestamp on, and then that'll help for confirmation later on. Then we need the transactions. So when we create our block, when we're getting ready to add the block to the chain, we are going to take all the transactions that we put in our pending transaction spot and put it in the block. So then we would delete all those in pending transactions. So then the next block would start storing theirs in there. That was weird. I think I bumped something. Nothing. I just heard a weird sound. Really weird. We got weird sounds, right?
Always.
So next we have in our block, we have the proof. This is super important, and we'll get back to that later, but it's basically to prove. It has to do with the mining. I don't have a good explanation from what I've seen on the screen. So you have to have proof that this block is unique, basically. And so we'll talk about that later. And then you have the previous hash. So you have a pointer, or you have the information of the previous block. So what was that previous block? And that is really important, because then that helps with being able to try somebody trying to swap out blocks. Because if somebody changes that previous one and it doesn't match up, then we know. So that's what our block contains. So repeating again, we have our index, timestamp, transactions, proof, and the previous block information. It's called previous hash. Pretty simple. I mean, not simple, but pretty small amount of information. Next, we have to do we have to be able to do things with this information, right? So in computer programming, we have what's called functions or methods or procedures, depending what language you're in. And I'm sure there's probably another way to describe that exact same thing. But what it is it's a code structure that you create, and you set up the rules of how to interact with the information. A lot of times you're allowed to pass a value to help, condition that rule, we'll call it, right? In this case, if you wanted to add a new transaction to the pending transactions list, you would want to send it, who's sending the coin, who's getting the coin, and how many coins are you sending? And always keep in mind, cryptocurrency is not whole coins. You can do decimal places out to many, many zeros. Now, you can't buy on exchanges very small amounts. I think $20 or $10 is the smallest amount I've seen. So they don't let you put in, but you don't have to buy a whole Bitcoin. If you want to get into the Bitcoin game, you don't have to buy a whole one for, there was a big crash today, so I think they're on sale, but somewhere around $50,000. You
Is
know,
that
let's see.
like a
Here, look.
Black Friday or Cyber Monday sale?
No, this is killing Christmas for all the traders sale now. No, actually, oh my gosh. Jeez. Yeah, it's bad. So Bitcoin has most of the crypto market, I think, today. If you're dating this against December 4th, 2021, both the stock market and the crypto had a big dip between yesterday and today. But it looks like 25% discount. So $46,000. But you don't, the point is, you don't have to buy a whole one. That was really the point. So you could buy $20 worth of Bitcoin. It's going to have a lot of zeros in it, but you can still own any portion of these coins. So when you're sending that transaction, it doesn't have to be a whole number. Was the whole point of that? I got a cough. Hold on a second.
Okay, cough away.
What? You still heard it? Oh my God!
You're that was an awesome.
My avatar did a nice cough.
Yep.
So we are still gonna have our intermission here in 7 minutes, like we try to do halfway through our hour. But it is very important. So we were talking about functions, and they are the way you interact with the information. So being able to add a transaction, and this is where the bugs come in, I believe, for when people don't have their code tested well enough for the cryptocurrency. But you have a sender, a recipient, and an amount. So that's the rules to be able to create a transaction. You can apply any other information. Maybe you need a PIN number or something. I don't know why you'd want to do that in this world, but so if you wanted other information, you could always require that, and they would have to send that information to be able to create the block within your code. So that's like the purpose of a function. A function applies rules and standards. I mean, it's kind of weird to say that, and requirements, and it lets you usually, set some filters or change the way, or you have to pass in the information, and then it handles the interaction. That's not always true, but in every language and in every computer program, but it should be for the most part. So then that is the function. So we'll need to add some functions to our block to be able to interact with it. Obvious, new transaction. Another one that would be useful is to get the hash. So now we're talking about, what was that? That was the last thing in our list, the hash. And the hash version is how you uniquely identify your block. And so then this guy's like, okay, it's time for the hoodie wearing Matrix style hacker. Oh yeah, don't read that. So cryptography. And then there's a cracked knuckles sound. Where's our sound effects?
Crack.
That's the best. I don't know if I've ever heard knuckles. Is that what eggplant knuckles sound like? Okay, I don't know if I'll be able to recover from that. Whew. So Bitcoin and many other blockchains use an encryption standard that's really powerful. It's SHA-256. I'm not going to get into what it is, but you have to convert your, we'll convert the block into Unicode. And Unicode is a computer programming standard that just allows everybody to communicate with text from different languages and different character sets all in the same character set. So there's a few standards that's been agreed upon in the programming world, but Unicode is the facilitator of that. And so then you pass it your string in Unicode, and it's just another function, and it spits out a 64 character long encrypted string. And it's basically nonsense, which to a person trying to read it, but it is super important to the blockchain. And so this hash, which is the encrypted Unicode text of your block, is applied to that block. And so the obvious question is, why do we care? And so blockchains are considered tamper-proof because every single blockchain contains a copy of the previous block's hash. So if you created the hash by the information contained within your block, if you change one character in it, it will give you a different hash. Right? Because it was created by every character in there. So, and then you put that on yourself. You're like, hey, this is my ID. You can't change any of my information without changing that hash. So then once you link up the next block to it, that right there keeps that last block locked in. So then you can't change anything. And then they go on to talk about download blockchain to my computer. Because we'll get in the second half, we'll really just get into the programming and looking at the code. So we'll probably come back and talk a little bit more because we do understand a lot of people that are listening aren't necessarily programmers and they're just trying to understand. But the point of today's session, before we go to break, I do want to build on the blockchain, right? The blockchain is a very important concept if we're going to get to NFTs, because the next step will be talking about how things work on the blockchain and then the fees. And the fees is where a lot of people don't understand. It costs money still to interact on these networks. And you pay the fees. It's usually just a little drainage off of your transfers. But there's a lot of different ways those work. And when you start getting into NFTs, you don't realize that you could try to buy something. And if everybody else tries to buy it, you may not get it. And you still have to pay the fees to try to get it. So when we start creating our NFTs, it's just really important we understand what the blockchain does and how it works. You don't have to understand every little last detail. But the really important parts is why you can't change it, what is contained in a block, which is just the transactions, a list of transactions. And then because they're getting ready to hopefully upgrade Bitcoin here in the next couple of years to allow a lot of people to pile on into one transaction. So if you don't understand how transactions work today, it's going to get even more confusing when they get the next upgrade. And then that'll make what the goal of that upgrade is to lower the fees. So, because then basically if you join in and a bunch of people get in, the more people that get in on a transaction, the better fee rate they get. So then that'll make it cheaper for exchanges and different financial systems to use the networks. So when we come back, we're going to look at the code. We'll kind of recap this first half really quickly, and we'll be back in a few minutes.
See you soon.
I gotta figure out how to turn the music on. There it is. That was interesting.
What's that?
I came back and I saw my neck like all broken or something.
That's funny.
I think my dad
I
texted me. I thought we were going to talk about Bitcoin.
My sister texted me and asked me. She said she couldn't find our show. I was like, "Well, we're actually live now, so."
That's like, it's funny. We'll address my dad's one in a second, but it's funny about your sister because we're not that's fault on us because we're not doing a good job to where even our own family can find our stuff. Right? It's just kind of funny.
Maybe that's it. We're like, don't watch it.
So,
not yet.
Dad, we've been talking about Bitcoin the whole time. The whole time. Because blockchain, that is what Bitcoin started. Well, I think blockchain started Bitcoin, but they created it in the end, I guess, to get Bitcoins. But so Bitcoins themselves, I don't know. Join our chat.
Well, it just goes to show how confusing this is.
Yes.
We're not the only ones.
Yes. And so reading right here. If I wanted to, I could download the Bitcoin blockchain. So,
hey, real quick, is our intermission music off?
Should be.
Okay.
It is. I don't see the bar jumping over on the on the fancy screen.
Like, this is important. We don't want to ruin it.
You know, maybe my dad needs to run our soundboard. You know what I mean? That would be really nice. That'd be helpful.
Yeah.
But then I don't know. You'd have to make sure probably wherever you run it on has a okay computer. I don't know if you could do it, you know, because then it'd be remoting me too. Oh, let's get back on track. So,
okay.
Bitcoins. Let's talk about Bitcoins for a second. The Bitcoin blockchain. That is what it is. Bitcoin is just another type of blockchain. Not type of blockchain, it's just it has its own blockchain. And it has its own rules and its own way that you interact. And so let's go to CoinMarketCap. And this is where I think some of the confusion is. Because when we talked about blockchains count for all of these. Like, I don't, maybe not all of them. I'm just thinking of one that might not be an actual, I think they interact with the blockchain, so that was an inaccurate statement. So only some of them are actual blockchains. Let's see if they have a cut down of that, because the other ones are things that interact with the blockchain. So I'll talk about the ones I know for sure. So Bitcoin, that is a blockchain. Ethereum, that is a blockchain. Binance, another blockchain. Solana, another blockchain. Cardano, another blockchain. And hold on, I got a cough. All right, so if you notice a theme, the top most valuable cryptocurrencies are blockchains. This one right here is supposed to be a guaranteed, like the gold standard used to be, where it's got US dollars backed against every coin. My coffee went down the wrong tube. So, and then you have USD. Don't be confused. This is not an officially endorsed US dollar coin. But I think XRP is a blockchain. Dogecoin's a blockchain. Now to get into here, like Polygon, that's a layer 2. And I don't want to confuse anybody, but they're an additional layer. So they might be a blockchain, but they interact with another blockchain. So they kind of sit on top, and it's only to lighten fees. That's what a lot of it is. And so
So I'm confused.
Oh, God. Yep.
Um, I was waiting to see if maybe we circled back. So what does that mean? It interacts. It just I don't understand.
So it would be like the way that I think of it is, I'm going to Google it, but the way that I think of it is as a layer two. So you have your Ethereum's the easiest one to describe on that. You have your Ethereum network, and everybody is doing their financial transactions on there. You know, just like what we talked about, they are creating blocks and they're being added to the chain, right? So every transaction of people transferring around Ethereum is being recorded in a block, you know, and they can, let's say they fit 10 transactions in their block. And then once you get 10 spots in, you commit the block and you move on, and then the next 10 people go into the next block. And every time you go to put that block in, you have to pay gas fees. And you might even have to pay the gas fees to get in the, yeah, you have to pay gas fees to even get a spot in the line. And the people that pay more gas fees get to get in line further, more in front, right? It's fast pass. And I'm hitting space on my space bar.
I know. I was just gonna say
Very
that.
distracting. I was like, where's this line thing coming across the screen at? And so, what is a layer two? So, back to, layer. What is a layer two crypto? So, when you're getting in line and you're paying your gas fees, if somebody pays more gas fees, they get to get in line before you, and then their block will be committed before your block will be, because you'll be bumped to the next one. And they do have conditions that if you have been waiting in line for so long, you eventually get a spot, right? They'll let you in. But it may be 3 blocks down the road, and that has really important consequences to prices and what's going on in the chain. So a layer 2 sits on top of that, and it helps smaller people get into the blocks. So you interact on the layer 2 and it builds a block up for Ethereum, and then it makes the call. So then the fees are far less expensive because they're saving money because they do it all in one big chunk. Does that make sense? I'm trying to think of like a real world where, okay. So, no, that wouldn't work. I was going to try to use like a travel agent because, but it's sometimes cheaper. It's just more convenient. I'm trying to think of where you would, okay. If you did an escape room and they charged per room, right?
Mm-hmm.
And when you go to do it, if everybody was doing it by themselves, it'd be a while before you got to go do yours, right?
Right.
So then this other company is like, hey, we're going to advertise to say if we group you up 8 people in an escape room, then we can get we can get priority, because then we'll call the escape room place and we'll work out a deal, or we'll pay them more or something. I don't know. It's kind of like we'll pay them more, but we can collect fees from you, but we can fit maybe 16 people in. And so then we make enough money that we can pay the room plus a little bit. So then we get in front in line. And then we collect your fees, but you get to move in front in line, but you're not paying as much as everybody if you were doing it by yourself. Does that kind of make sense? I didn't explain that too well. So let me try again. So when you're grouping up, everybody would just pay a little bit of money. And that adds up to a lot of money, right? If you're piling people into a hotel room or something. But it's the escape room's easy. So the more people you get in, the more it is cost effective. The company that's handling that makes money off of piling people in, and then they can pay the escape room people, which is Ethereum, a higher gas fee to get their block committed, to get their spot in.
But it's less for
But it's less for each individual transaction. Yep.
Because there's going to be more of them. So they individually pay less because combined they're paying more.
Yep. Yep.
Okay.
Yep.
Okay. I think I get it.
Yep. And they don't pay the full amount, right? Because that layer 2 takes, their cut because they're handling that actual interaction. So they win, the individual buyers win, and it does also make the chain interaction more efficient for Ethereum. So layer 2s do help. But the question is, on these layer 2s, which would be like Polygon and a few others, what happens when Ethereum finally releases their code update and gets their fees lower, if they ever do? Because right now gas fees are insane. Like, we're talking hundreds of dollars to do one transaction. So if you want to do a transaction on Ethereum and you're not part of this layering system.
And if I understand correctly, so if I'm going through Ethereum and I pay some gas fees, just because I pay hundreds of dollars doesn't mean that I'm going to get in right away, because somebody else could be paying a lot more and bump me back.
Yep.
Okay.
You'll eventually get picked up. So it's like a priority list, right?
Mm-hmm.
So I'm showing the Ethereum gas tracker. It's just a spot you can go to. And so we've gotten way off track.
No, we're supposed to look at code.
Yeah. So, but it is important to understand that these blockchains, that's how, not everyone is a blockchain, but basically they're all operating in the blockchain idea, because the layer 2 is still doing the same thing. It's just kind of grouping them up, and then it creates its own block, right? So Polygon creates a Polygon block of people, which the fees are much less. Like, we're talking dollars or pennies or stuff like that, instead of, I think I just saw almost $100. Gas fees are actually kind of low right now, probably because of the crash. But then they're doing their thing, and then they will create an Ethereum block for all those transactions. So that's kind of how that works. So it's all just a bunch of blockchains, but Bitcoin itself is a blockchain, and there is only so many coins that can be ever mined, and it's like 21 million. And so currently there's like 18 million or something like that, 19 million. But that will get back into the code now. So I'm going to show the code again. Oh yeah, we're going to zoom in. I don't know if Grandma messaged. Let's see. How do I zoom? It's not working. Thought it was Control Plus. There it goes. Ooh, it was just slow.
Hello.
There we go. Nice big code. Because I do agree, when I'm screen sharing at work, it's hard to see sometimes. So just like what we were talking about, our chain is just a list of blocks. Blockchain is just a list of blocks. And within that, we have information in those blocks. And then we have here, you don't have to understand anything. It's just pending transactions. So these are two variables that we're allowed to use. So it's a list of transactions and a list of the blocks. And then we define our index, our timestamp, the transactions. We still got to circle back to this proof. And then we talked about the hash, which is an encrypted Unicode. It's just an encrypted version of the block. That's the easiest way to think of it. So it's a 64 character encryption key that you can also get back out the information from. So it's unchangeable. So if you change any information and try to do it again, you'll never get two of the same things. I mean, if it was the same information, always the same result. Different information, always a different result.
Okay.
And then we have our functions, which we talked about. Functions are ways to interact with the blockchain. So creating a new transaction, creating the hash. This is where we convert it to Unicode and then encode it and encrypt it. Okay. And this is the famous starting. We should clean this up.
Oh, that's not how you spell pretending.
Why not? And why is there a big R here? Man, everybody's so mean to me. So we have our code. So this is our blockchain class. And over here, we're going to use that blockchain class. So there's the file. And then we're going to use that blockchain. And this first line is going to initialize it. And so what that looks like is when we create our variable, when we create our blockchain, the very first thing it's going to go do is create the Genesis, the very, very, very beginning entry. And it's going to be based off of something that is set. So then everything off of that keeps building, just like what we talked about. So that's the initialization. And then we're going to do some transactions. So here, we don't got to worry about any of this front part. We're just going to do a new transaction. Darcy's going to give Jeff 5 PTP coins or Bitcoins for those that want to buy and sell Bitcoins. Then Natalia's going to give Darcy 1 PTP coin. And then Jeff's going to give Goron 5 that Darcy gave him. And we're not going to see how many everybody has with the code that we currently have, but maybe next week we will. We're going to do NFTs next week, but they could be next week also. And then we're going to commit that block. So what do we do up here in this code? So here with this code, we initialize the blockchain. We put some transactions in a block. And then we committed that block to the blockchain. And then we did some more transactions and committed another block. So what we're going to do is now look at that blockchain. That's what this print does. So it's going to print out the blockchain. I'm going to run this and maybe it worked. Maybe it didn't. We never know.
It did.
Except for it didn't pick up my change. Why?
What do you mean?
Right here.
Oh, it sure didn't.
Kind of weird. Whatever. It's irrelevant for the point of the discussion. So we are going to copy this out and going to look at it. This is an analysis of our chain. Oh, ooh. Look at that handsome guy. They didn't get to see it. It was just the bear on the green screen. It was kind of funny.
Oh, yeah, I saw it.
Yeah, she saw
That's
it.
funny.
Oh, I'm not prepared for this. We're going to need to look at it in VS Code. I was going to open Notepad, but since it doesn't like sorting it anyways, what does it matter?
Mm-hmm.
This is so small. All right. Okay. So when we're looking at our chain, if you guys remember, we created the initialization. And so this is the very first one with no transactions. So it's empty transactions. This is to initialize your blockchain. So let's start it up. And even though our message isn't what it's supposed to be, this is the message that we started with. Somebody already hacked our blockchain right off the bat. That's the best part. It's like,
it's a good thing we decided not to do this for realsies.
Yeah, no for realsies. So this is the initialization. That's index number 1. Here's a timestamp. And then the proof is what we sent, I believe, in this spot. See where it says proof? Mm-hmm. So we passed that as a variable. That looks good. And then, so that looks good. Then we have the next one. And if you remember, this is where we added 3 transactions. So let's go look for our transactions. So if somebody went and looked at this block, and that's what some of the cryptocurrencies over here that we were looking at a second ago. How do I do this? There we go. What they do. So if you look at, for instance, Chainlink isn't, I'm 99% sure it's not a blockchain, but it has its own cryptocurrency. So in a way, it's a blockchain, you know, and it says it is a blockchain. Oh, it says that it's that blockchain abstraction layer, but it's, we'll have to get into smart contracts. So another thing we'll need to talk about, but it's something that sits on top of the blockchains and looks and reads them. And when we want to look at what happened in block number 2, we're going to break that one down. And so here's the transactions. And if you've ever worked in accounting, this is basically a ledger of what's going on. And here you have Darcy, and then it says the recipient is Jeff, and the amount is 5 PTP. So that's what happened. Same thing. This is what we did. So every time that somebody goes to an exchange or wants to interact with the blockchain, if they have it like on their own wallet loaded on their computer and they want to transfer things around, they would send a transaction up and eventually it would get committed to the block. And this is what it would look like after you're done. So you could go look at the block that you're part of and you would see, hey, here's my transactions right here and right here. So I had 5 PTP, which are priceless, and then I gave them away. So Goron has my priceless PTPs now. And if I wrote another function on my blockchain class, I could look at what somebody has. Or I don't even have to have that as part of the class. I could just read the blockchain and figure it out for myself. And then if you break down the rest of the transactions, so here's the timestamp. And since they all happened at the same time, it's going to have pretty much the same timestamp. We'll put a pause in to get a different one. How much time do we got? We got 2 minutes, so we got to go fast. Here's the proof. So if we look over here, look, there's the number that we passed as our proof. And then here's the previous hash. So this is that encrypted hash of right here. And then if we come down, here's our second one. Well, third block, but second set of transactions. And as you see, we can do decimals, so they don't always have to be whole numbers. And we had more crypto transferred around. And so when they talk about the blockchain, all it is a big list like this of what's happened. And so if somebody tries to change any value in these transactions, or really anywhere, when it encrypts it, this is going to change. Because if you look, even though it's super messy, it's definitely not the same as the next one that got created. Okay? And so since we have this, let's do one quick example. We're going to go just a few minutes over. I want to run this again, but I'm going to change one thing. We're going to change this 1 to 2. So right here, Natalia gave Darcy 2 instead of 1. Such a small, we don't even have to do that. We could keep that the same. And now we're going to do PTC, right? Just something different. It doesn't even matter. We're going to run this again. Copy that. Bring it over here. So here's our first run up above us. And what I want to show, I'm just going to try to get real quick to
Oh, you grabbed the first example. You'll have to grab the second one. I mean, it's right under, see where it says Genesis block again, right under where you are. That's the new one.
Gotcha. Thank you.
Yep. Teamwork.
Yay. And I couldn't imagine doing a live stream by yourself. That would be tough.
Yep.
It's a lot to manage. Be super efficient. All right. So, very quickly, all we changed was one character. Everything else is identical. Look what happened in the first 2 characters here. You don't even got to read the rest of it. We got 6B and 6E. So that's why this is a really powerful concept, because everything changes. Now look, because that changed, this next one changed. All because of one character. It didn't matter what we changed in here. Because of this text gets grabbed and then it gets encoded and encrypted. The moment you change one character, everything changes. And significantly. Like here it wasn't as big of a change. I mean, it did, but you know, you still had the 6. What are the odds that lined up?
Mm-hmm.
But then after that, it just is done. And this has never changed. That's what's really cool.
That is cool.
So if somebody tried to come in and hack this, they can't. And that's why the concept of the blockchain is really, really powerful. Yeah, we'll save that. I don't like my autosave not being on. So, do we get any questions before we go?
Nope.
No.
No questions.
So sad.
Yep. Maybe next time.
No. No.
Probably not, though.
Yep, probably not.
But that's okay. There we go.
Yeah, and so if
Oh, wait.
you... Oh, what? No. Oh, wait. That was the best. Wait. Oh, wait. No.
We did get some comments.
Oh, our comment person is failing?
Yeah. Patricia was saying the music is off. And then it said my screen is not changing, but I think I missed it.
Well, I'm pretty sure. Yeah, I'm pretty sure you missed it, because that was probably like the music off part was right when we came back 30 minutes ago.
About a half an hour ago.
And then I zoomed. I don't remember when that happened. And then she said her screen's not changing. I'm not sure why that wasn't changing. We'll have to. It probably just took a second, maybe. So here's this. Yep. And if you guys want to, if everyone wants to learn more about individual coins, CoinMarketCap, click on the coin that you want, and you can read all about it. So.
Awesome. I think
all right.
I learned a lot today.
Next week, we will be covering NFTs in depth. And any questions, if you have any questions, please post a comment on our video and we will answer it or we won't.
Yep.
That's a binary thing.
That's it.
That's it. I mean, there isn't anything else. So, but if it is something that we can discuss, and if you want a little more discussion, maybe we'll talk about it next week. If you need more clarity on anything we showed today, please feel free to ask, and we'll quickly cover it again, because this is a lot, and it's very important as a foundation to build on what we will cover that is a little more fun than this. But it is really important to understand the concepts that, and I know people can't see what I'm showing because I switched. The concepts of what makes up a block. What is a block and what is the blockchain? After that, it gets a little easier. Not much, just a little bit.
Tiny bit.
All right, everybody have a good week, and we'll we have Business Central, I think, on Tuesday or Thursday. Just check our website. What's our website again?
Pretendingtoprogram.tech.
Yeah. Oh, my dad said that his wife was dancing. It's funny. So
To our intermission.
to our intermission music. So that's really good.
So we don't need new intermission music.
Yeah, we do. We need variety. Well, then I mean, maybe she won't dance as much after. Who knows?
Okay, then.
We don't know. Maybe
We
our
either will or we won't be changing our intermission music. We'll see.
Yep.
It'll be a surprise.
it'll be a surprise.
Stay tuned.
Stay tuned on the edge of your seat. So.
Yep.
All right.
I'm only watching the show to see whether or not there's new intermission music.
Well, isn't that like with the commercials for the Super Bowl, where a lot of people just watch for the commercials? They don't care less about the event. So it's the exact same thing. Nobody cares about cryptocurrency. Nobody cares about what we have to say. They're just, are they gonna have new hats? Are they gonna be playing new music? That's important
New
stuff.
sound effects.
Yep. I don't know. Stay tuned. We're gonna change it up. It's gonna be crazy over the next few weeks, or not.
Yeah, or not.
All right, everybody have a good day.
Bye.
I gotta figure out how to stop it.
You can do it.